Hello everyone. Today we are going to start our class with the first topic is the mechanism of micelle formations. As I said, micelle is the aggregation of colloids, or you can say colloidal particle at the critical micelle concentrations. Okay, there should be critically micelle concentrations. If the concentration is low, then it could not be said micelle, but at the CMC it is formed. Now see how. Mainly the mechanism of micelle or micelle formations is important for the soap and the activity of soap. For soap, okay, for soap, the one of the major, you can see the main component, soap, 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 the major component is long chain fatty acid. Long chain fatty acid. This fatty acid is mainly potassium and sodium salt of fatty acids. Mainly potassium or sodium salt of fatty acid. Let us take an example. Which fatty acid is healthy? Now, see. A well-known example is the sodium stearate. Sodium stearate, which has the formula of CH3 CH2 whole 16 CO negative Na positive. Here it is sodium. That means sodium salt of sodium stearate. That's why it is known as salt of fatty acid. Okay. Now, see. If we draw this one as a chain form, okay. Now, what will we get? We are drawing in a chain form. Okay. CH3, this one, CH2, and this. Okay. This one is the chain structure, or you can see the complete structure of sodium stearate, where here is the ion and is the cation. Okay. Now, as I'm said about the hydrophilic or hydrophobic, or you can say lyophobic or lyophilic. Okay. Now, see. This one is the what? This one is the hydrocarbon. This one is the hydrocarbon, which is lyophobic in nature. Lyophobic in nature. That means liquid or solvent repelling. Liquid or solvent repelling. That means it heads the liquid. But this one is what? This one is hydrophilic, and this one is known as hydrophilic tail, because it is looking as a tail, and this one is hydrophilic head. Like it's a hydrophilic part, this one is hydrophobic part. Okay, nothing matter. Now, see, main thing is that since it is liquid repelling, no, that's why it is hydrophobic, and it is liquid loving, that's why it is hydrophilic. Now, when we add this any soap or any detergent having the sodium stearate solution in the water, then obviously it will dissociate, no? To dissociate, that means it produce this one negative plus Na positive. This negative ion, that means this negative part, is the hydrophilic head, or you can say hydrophilic part, which loves the water. If it loves the water, then obviously it will react with water. Okay, or you can say it will attach with water. But this one, this chaining group, that means this hydrocarbon chain, is water repelling. That's why it is hydrophobic tail, I'm saying. Due to this hydrophobic nature of this hydrocarbon, these are water repelling. That means it does not react or does not attach with water. Now, how they situated in the solutions? Let us see. Suppose we are writing this sodium stearate in the some simple way. Okay, suppose we are writing this one is the hydrocarbon chain and this is the negative. Negative means hydrophilic head and hydrophobic tail. So this one is the hydrophobic part, and this one is the hydrophilic part. Now suppose we have taken in a bucket some amount of water. Now when we add this compound, that means sodium stearate at low concentrations, obviously it will dissociate. No, it will dissociate. Suppose if we taking a low concentration, suppose I am taking this way. Since it has a low concentration, that's why I am using only 3 molecule. Okay. Now see, this is hydrophilic head. That means water loving. That's why it is attached with the water. But this one tail is the hydrophobic. That means which repels the water. That's why these are not attaching with the water. Okay. Now see, at the critical micelic concentration, that means when we add sufficient amount of sodium stearate to aggregate, and that concentration is known as critical micelic concentration, as I am explaining. Okay. Now see, at the CMC, that means at critical micelic concentration, what will happen? At critically micelic concentration, suppose this is a big beaker, or you can say big bucket. I am taking lots of water, and this one sodium stearate, now it is CMC. At CMC, that means at critical micelic concentration, then it produces a globular type structure. Now see how it's globular type structure. Remember, this one is water repelling, this one is water loving. Then it produces this way. This way, and produce a globular type structure. Now see, these three, this minus R signifies the water loving part. That means hydrophilic. This hydrophilic is directly attaching with the water. Okay, but this hydrophobic part, that means this hydrocarbon part is in between. That means in between a spherical type molecule, so that it cannot attach with the water because it is water repelling. In this way, at CMC, the formation of micelle takes place. Now see, it is all anion, no? Or you can say ion. Simply you can say ion, because when we add sodium stearate, obviously lots of potassium positive ion also there to neutralize this ion. That's why it is known as ionic micelle. Ionic micelle. And the process is known as the mechanism of ionic micelle. Okay. Now see how ionic micelle is used in the cleaning action of soap. Cleaning action of soap. as I'm said, this formations of aggregate, that means micelle, helps in the cleaning action of soap. Now let us take, here is a simple surface of cloth and here is the dart. Now dart is a, suppose dart, and dart is a oily type substance, you can say, or oil or grease, oil or grease types of substance, which is water hating, not water loving. Now 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 at small concentration, or you can say at low concentrations, when suppose here is a bucket, no, there is, suppose here is a bucket, water is there and this is a dart surface there. When we add detergent, or you can say soap, soap means sodium stearate, when we add sodium stearate at low concentrations, then the water repelling part of that sodium stearate, that means this one is hydrophobic and this one is hydrophilic. This one is hydrophobic, that means water hating. This hydrophobic part will attach this way. Now when we add at CMC, that means at critical micelle concentrations, then obviously globular types of aggregation takes place. How? Now see how. At CMC, the globular types of substance like this way. Like this way. This one is the hydrophilic head. This dart, due to the nature of the, or due to the oily nature of the dart, this oily group, that means dart, is attached with this water repelling part. Now here is the dart. Now the main thing is here. This dart is comes with the aggregation, that means in between the micelle. Due to this water hating component, that means oily substances, this dart are enclosed in between the micelle. Okay. Another thing is the, this negative charge, that means the hydrophilic part is water loving and it is attached with the water. Now due to the water loving character of this hydrophilic head, these molecules, or you can say the dart, comes out from the dirty surface of our cloth. Okay, and when you wash this cloth with a simple normal water, this aggregation is taken out from the container, you can say cloth, and this way we will washing our clothes with the help of any soap or detergent. Okay. Now the next topic is the preparation of colloid. Okay. Now how we can prepare the different types of colloid. Colloid can be prepared with the help of some chemical reactions. These chemical reactions are the maybe oxidations, maybe displacement reactions, maybe hydrolysis reactions. Okay. Now see one by one. First, number one is the, suppose, double decomposition reaction. When arsenium oxide reacts with hydrogen sulfide, this is double displacement reaction. Okay, and it will produce arsenium sulfide. That means arsenium sulfide is the colloid. That means salt plus 2 molecules of water. Okay. Next reactions. When sulfur dioxide is reacted with 2 moles of H2S, it is oxidation reaction. It will produce sulfur salt plus what? 2H2. Third chemical reaction is when 2 moles of aluminum chloride reacts with 3 moles of formaldehyde plus 3 moles of water, it produces gold. So this one gold chloride. Okay, gold produced gold salt plus 3 moles of formic acid plus 6 moles of HCl. And fourth one is the hydrolysis reactions in between FeCl3 plus water. Simply hydrolyzation, it produces FeOH 3 plus HCl. This one is a salt. That is correct. It is defined as the process of conversion of precipitate into colloidal solutions by shaking it with a dispersion medium. Okay, dispersion medium in the presence of small amount of electrolyte.